Now in this sum of exercise 6.5, you are given that prove 3 times the square of the side of a equilateral triangle is 4 times the square of the altitude of that equilateral triangle. Okay, it is given in a statement form. So we have been given that triangle ABC is an equilateral triangle where AD is the altitude. What you have to prove is 3 times AB square is equal to 4 times AD square. So proof is very simple. You just have to remember the property of an equilateral triangle, that if a triangle is equilateral, then its altitudes, medians, angle bisectors, perpendicular bisectors are one and the same. तो इसमें ये जो altitude है ये median भी हो गई, मीडियन हो गई है, इसलिए पॉइंट डी क्या हो गया, मिड पॉइंट ऑफ बी सी. गेटिंग दैट? सो वी राइट दिस फर्स्ट एज ट्राइंगल ए बी सी इज इक्विलैटरल, therefore altitude AD is also the median. Therefore, BD is half BC. Okay, BD is half of BC. So BD square will be equal to 1 upon 4 times BC square. Squaring both sides. This is your 1, squaring both sides. Okay. Now we apply Pythagoras theorem for this right triangle ABD. I hope you can see this triangle ABD. So now in right triangle ABD, angle ADB is equal to 90 degree. So by Pythagoras theorem, so you have AB square is equal to AD square plus BD square. So AB square will be equal to AD square plus, what is BD square? 1/4 of BC square. So 1 upon 4 times BC square from 1. Multiply the equation by 4. So therefore 4 times AB square will be 4 times AD square will be equal to BC square. Multiply by 4. Getting that? Now as triangle ABC is equilateral, therefore BC will be equal to AB. Correct? So in place of BC we will put AB. 4 times AB square is 4 times AD square plus AB square. Since AB is equal to BC, as triangle ABC is equilateral. Fine. Transfer AB square to the left hand side. So that will become 4 times AB square minus AB square is 4 times AD square. 4 minus 1, that makes 3 times. Thrice AB square is 4 times AD square. Hence we have proved the required condition. Now we move on to the optional exercise of your lesson, that is lesson 6. We take the first sum. In state board, this sum is given as a theorem, the angle bisector theorem. Okay, so we have to prove the angle bisector theorem. You are given in triangle PQR, PS is the angle bisector. Of which angle? Of angle P. You have to prove QS upon SR is equal to PQ upon PR. In state board, as I said, this is termed as angle bisector theorem. Now in this, what we have to do is, we have to draw a line parallel to this ray PS. Okay, so a line parallel to PS. and let it intersect QP in some point, say we call this point as T. Okay, so what have we done? We have drawn TR or RT parallel to PS. So this we have to write in construction. So in construction you'll write, draw RT parallel to PS. Okay, now in your proof, we'll make use of the properties of parallel lines. If two lines are parallel, then the alternate angles will be congruent. This angle SPR will be equal to this angle PRT, and this angle, that is angle QPS, this angle will be equal to this angle T, because these two lines are parallel, so corresponding angles will be congruent. These form a pair of corresponding angles. These two angles are alternate angles. So let us do this. We begin in triangle. Now I am taking the biggest triangle. In triangle QTR, PS is parallel to TR. Okay, so for transversal, first the transversal that I am taking, for transversal PR, this PR, you have a pair of alternate angles congruent. Angle SPR is equal to angle PRT. This is your one. You'll write since alternate angles. Now we change the transversal. Now for transversal QT, now lines are the same, parallel lines are the same. Now for transversal, which is the transversal QT we are taking. So angle QPS will be equal to angle T. These are corresponding angles. Okay, but now what actually is this but? But you have angle QPS. Angle QPS is equal to angle SPR. Why? Because PS is the bisector of angle P. So but angle QPS is equal to angle SPR. This is your 3. Reason is since PS is the angle bisector. Fine. Therefore, from 1, 2 and 3, from 1, 2 and 3, what do you get? The left hand side becomes equal. If these two angles are equal, the left hand side is equal. If the left hand side is equal, the right hand side will be equal. So from 1, 2 and 3, angle PRT is equal to angle T. Now have a look in the figure. This is your angle PRT, which is equal to angle T. So the sides opposite to congruent angles will be congruent. Therefore PT will be equal to PR, which we call as the converse of isosceles triangle theorem. So therefore you will have PT equal to PR. This is your equation 4. Since side opposite to equal angles are equal. Okay, so now we move on to the biggest triangle. Now we take triangle QTR. Now in triangle QTR, PT is parallel to RT. Sorry, PS is parallel to RT. Right? This PS is parallel to RT. So we are going to apply the basic proportionality theorem or the Thales theorem over here. Therefore, look here, this is the triangle. Line is parallel to one side of the triangle, so it will divide the other two sides in the same ratio. These are the other two sides, QR and QT. So you will have QS upon SR equal to QP upon PT. So in triangle QTR, PS is parallel to RT. Therefore, QS upon SR will be equal to QP upon PT by basic proportionality theorem. Now just now we have shown PT is equal to PR. So in place of PT you will put PR. Therefore QS upon SR is equal to QP upon PR from equation 4. And this is what you had to prove. This is what you were expected to prove. See, QS upon SR is PQ upon PR. Got that? This theorem, this is a theorem in state board called as the angle bisector theorem for a triangle, an application of basic proportionality theorem.